everyone. Today we will discuss one more very important topic of digital electronics, that is Demorgan's theorem. Now the question is, state and prove Demorgan's theorem. You may find this question of 2 to 10 marks in different engineering semester examination. You may also find this question in 12th examination of different board. This question generally comes in GATE, NET and other competitive examination also. Now Demorgan has two theorems. The first theorem, theorem 1, states that the complement of the sum of two or more variables is always equal to the product of the complement of the variables. Now mathematically, if you will say a plus b plus c complement is always equal to the a complement dot b complement dot c complement. And if you will take two variable equation, then it can be written as a plus b complement is equal to a complement dot b complement. Now theorem 2 states that the complement of the product of two or more variables is always equal to the sum of the complement of the variables. Mathematically it can be written as a dot b dot c whole complement is equal to a complement plus b complement plus c complement and so on. Now for a two variable equation, it can be written as a dot b whole complement is equal to a complement plus b complement, or a bar plus b bar. Now let us prove theorem 1. A plus b whole complement is equal to a complement plus b complement. Dot b complement. Now this theorem can be proved by the help of two methods. The first method is complement law of addition method, which is x plus x bar is equal to 1, and complement law of multiplication method, which is x dot x bar equal to 0. Now let us assume a plus b is equal to x, then definitely a plus b complement, which is equal to a complement dot b complement, is equal to x complement. Now if this theorem holds true, we can write x plus x bar is equal to 1. Putting the value of x and x bar on LHS side, we can write a plus b plus a bar dot b bar. Now we will apply distributive law here, and it can be written as a plus b plus a bar dot a plus b plus b bar. Now by the application of complement law of addition, we can write a plus a bar equal to 1 and b plus b bar equal to 1, and the above statement will be 1 plus b dot 1 plus a. Now according to the annulment law, we know 1 plus any variable is always equal to 1. So it can be written as 1 dot 1, which is equal to 1 and is the RHS of the above equation. Hence it is proved. Similarly, we can prove the statement theorem by the help of complement law of multiplication method. Putting the value a plus b dot a complement dot b complement. Similarly apply distributive law. The statement can be written as a dot a bar dot b bar plus b dot a bar dot b bar. Now complement law of multiplication method states that a dot a bar equal to 0 or b dot b bar equal to 0. Now this can be written as 0 dot b bar plus 0 dot a bar, and 0 dot any variable is equal to 0 according to the annulment law. And finally the answer will be equal to 0, which is the RHS of the theorem. Similarly, theorem 2 can be proved. Theorem 2 states that a dot b whole complement is equal to a complement plus b complement. Now again, complement law of addition states that x plus x bar equal to 1, and complement law of multiplication states that x dot x bar equal to 0. Again, assume x is equal to a plus b, then definitely a complement plus b complement will be equal to x bar. Now putting the value of x and x bar on LHS side, we can write a dot b plus a bar plus b bar. Applying distributive law of addition, it can be written as a complement plus b complement plus a dot a complement plus b complement plus b. Now complement law of addition states that a plus a bar equal to 1 and b plus b bar equal to 1, and the statement will be 1 plus b complement dot 1 plus a complement. And we know, according to the annulment rule, 1 plus any variable will always equal to 1, and the final result will be equal to 1, which is the RHS. Similarly, complement law of multiplication can be proved by putting the value of the variables x and x bar. Again, apply distributive law. A dot b dot a bar plus a dot b dot b bar. Again, a dot a bar equal to 0, b dot b bar equal to 0, and the statement will be 0 dot b plus 0 dot a. The final result will be 0 plus 0, which is equal to 0. Hence it is proved. So in this way you can prove the Demorgan's theorem, which will be very helpful in semester examination and other competitive examination. Thank you everyone. Thanks for watching.